Hello from Chem Help ASAP. In this video we shall see the conversion of an alcohol into a leaving group and then displacement of the leaving group in an SN2 reaction with a strong nucleophile. This reaction sequence was reported in a recent issue of Organic Process R&D by William Goundry and a team of scientists at AstraZeneca in the UK. The citation will be on the following slide and in the video description. Here is the synthetic transformation. It starts with a primary alcohol and ends with an S-methyl in place of the alcohol. This transformation highlights a very common challenge in organic chemistry, replacing an alcohol with a nucleophile. Alcohols are not good leaving groups, so the first step is to convert the alcohol into a leaving group. So make our leaving group followed by our SN2 reaction. There are lots of ways to convert alcohols into leaving groups. The scientists at AstraZeneca selected mesyl chloride, or MsCl. Mesyl chloride stands for methane sulfonyl. That's mesyl. Here is the structure of mesyl chloride. So it has a CH3, an SO2, and a Cl. That is mesyl chloride. Many organic chemistry texts do not teach about mesyl chloride. I confess I do not teach this reagent in my own class. Almost all classes, however, do cover tosyl chloride. That is TSCl, which is tosyl chloride. Tosyl chloride, just like mesyl chloride, converts alcohols into good leaving groups, and here is the structure of tosyl chloride. The reagents are structurally very similar. You can often use tosyl chloride and mesyl chloride interchangeably. Great, so we have a leaving group here in our middle structure. We've made our mesylate. More formally, you might call the mesylate a mesylate ester. The mesylate then reacts with sodium methanethiolate in our second reaction. We'll put our charges into place. The sulfur attacks the electrophilic carbon and breaks the CO bond. Now that we have kicked out our leaving group, we can see better why the mesylate, now the mesylate anion, is indeed a good leaving group. So here is our anion, our leaving group. The anion formed has multiple possible resonance forms for delocalizing the charge around all three oxygens. The two steps in this sequence have been highly optimized and occur in nearly quantitative yield. Note that the rest of the molecule is unaffected, unchanged by the reactions at the carbon of the alcohol. While the product molecule is very nice in its own way, the product was carried forward by the AstraZeneca team to make the molecule shown in the bottom right corner of the slide. This is AZD6738, a molecule that is currently being evaluated in clinical trials for the treatment of certain types of cancer. You can see many of the features of our SN2 product included within the core of AZD6738. If you're interested in how the synthesis of AZD6738 was completed, use the citation at the bottom of the screen to find the full details. The chemical pathway from AstraZeneca is a great example of how organic reactions, like the SN2, are directly relevant to scientific challenges, including the discovery and synthesis of new pharmaceuticals. Please subscribe, like, or leave a comment. Take care.